Welcome students to Six Sigma Green Belt, lesson number 15. If you look at table of contents, we are still talking about the origins of Six Sigma. Today we'll complete this section, and then lesson 16 is going to be about organizational drivers. So moving forward, today we'll talk about Dr. Taguchi, and this slide is actually attached to the presentation, so you can read it when you feel like. And the next is also attached as a reference material to the presentation so that you can read at your own convenience. So we'll talk about these two slides today, and we'll end up, and that will conclude the biographies of all the pioneers that we have discussed so far. So going back to Dr. Taguchi, what he did was, Dr. Taguchi, he lived from (1924) to 2012. And what Dr. Taguchi he did was, he was a consultant for one of the firms in Tokyo, and was also the past director of the American Supplier Institute. He was also called the father of quality engineering, and you'll see why, and you'll learn why he was called father of quality engineering. These are some of his awards. The first award is the Deming Prize that he got in 1960. Second one was the Rockwell Award back in 1986. Third one is the Purple Ribbon Award, 1989. And fourth one is the Indigo Award in Japan, 1989. Then he got a medal from ASME in 1992. These are some of the books that he published. Number 1, System of Experimental Design. It has 2 volumes. Introduction to Quality Engineering and Offline Quality Control. These are really good books. So we'll talk about and discuss the statement on quality and his abstract in detail, so that it's easy for you to understand and prepare yourself better for the exam. So moving on to talking about Dr. Taguchi's statement on quality what he meant was, basically, whenever we see a financial loss in society that is somehow related to quality. And these two things are basically caused by the product's performance throughout its life cycle. So it's caused by product performance throughout the product's life cycle. Let me erase that. So that was basically his statement on quality. Now, talking about Dr. Taguchi's abstract, he created quality techniques back in 1950. So his quality techniques, what they helped was so these quality techniques helped to develop products or processes in a fraction of time. If you see these days, it takes way too long these days to come up with a new product in the market. So Dr. Taguchi's techniques, it helped to reduce that time so that the products could be made faster and brought to the market in a fraction of time. So even today, it takes years and years to develop a new product and bring it to the market. And his techniques showed how to reduce all this. And this is in some companies and not all companies, but majority of the companies we do see this. And Dr. Taguchi, to assist the American industry in quality improvement he visited America in 1980. So based on his teachings, and methodology, Xerox and Ford promoted his methodology internally and with external suppliers. What's unique about his system is Taguchi's system is a complete system. And what that means is it includes the time when we came up with the product concept, and then moving on to the design phase of the product, and after the design phase is completed, bring the product to the manufacturing plant for production. And this made his system unique and made it appealing plus unique to the public. Also with his system, we can optimize product design, and processes. And that can be done in a very cost-effective manner. And keep the costs to the minimum. So his methodology followed a different path for product quality and it includes the following 3 steps, and we'll talk about that a little bit in detail. Number 1 was quality evaluation. Let's say we want to evaluate of not meeting the target date or value. So this includes 3 steps. Number 1 is evaluation of quality. Under this, cost of not meeting the target value or the date. You can do that by, so this can be done by his loss function plus signal to noise ratio. And don't worry about the loss function and signal to noise ratio right now, but for now just keep in mind how can we evaluate the cost of not meeting the target value. And these two things, the loss function and the signal to noise ratio, can help us achieve that. Normally, we look at product in a way whether it meets the spec or not. This is a traditional, normal way, and we do this even today in many companies. Dr. Taguchi, he said that the quality loss increases parabolically. And just to show you what I mean by that is, that's what he's talking about when he says the quality loss, it increases parabolically. For now, don't worry about this. It's technical, but we're not going to cover in this section about this step because we're just talking about Dr. Taguchi's biography. So moving forward, number 2 was quality improvements and cost factors. Under this, if you know, we always should use statistical methods to evaluate any process or a product. So we always use these statistical methods for: one is whatever spec limits are for the product, that we can say as parameter design. Second, we use these for system design. And finally, we use that for coming up with the spec limits, and that can be said as tolerance design. So the above methods includes the quality improvement and the cost factors, but the following three methods can be used to achieve what we discussed above. And that was about the quality improvement and cost factors. So you can use these three steps that we're going to talk about to achieve number 2. So one is QFD, which is known as quality function deployment. That's quality function deployment. Second one is signal to noise ratio, and the third one is DOE. That's basically design of experiments. We'll cover this in detail later on. And number 3 was to monitor and sustain quality improvements. So our goal should or goals should be always to reduce variation in a process or on a production floor. What I mean by that is, if you have a process which has a huge variation, it's going to look something like this, as compared to what we need is something like this. So this is not acceptable and this is acceptable. So there's too much variation here and there's less variation there. So this is what we need to really go after. The other thing we can do is we can implement standard work as an example to have consistent processes or process. And then what we need to do is measure quality analyze it monthly, weekly, however you want to do it, and improve based on the data. So always make data-driven decisions. You will get a lot of buy-in if you have data to support what you want to improve. Methods so Taguchi's methods show us how to make something. Happen. Whereas statistical analysis or methods tells us what has happened. So there's a difference between the two. His methods show how to make something happen, whereas the statistical tools that we use, they tell us what has already happened. Nowadays, the concept of robust product is being explored in the industry. And what helps us is this reduces cost of poor quality. It could be any warranty failures that we see in the field, or any internal failures that we see within the company. So if a product is robust, it will reduce the cost of poor quality. The key thing to remember is always be consistent. And when we have this process in place, this will produce a robust product. So consistency is very important. When we have robust products or processes, they are less sensitive to any uncontrollable variation or variables. So when we make something, we need to make it to the nominal. The reason being, let's say you start up a machine, injection molding machine, you make a part, and you are in between where you need to be, you're meeting the target, and you're going to run the molding machine for about a week continuously on all 3 shifts. If you don't make the product the very first time at a target rate, what's going to happen is eventually there's going to be a process shift, and that product can fall out of spec, and then it can contribute towards the cost of poor quality. So it's very important that whenever we make something, we make it to the nominal. And this is the key to success and producing quality parts. Taguchi's methods in Japan, about 50% of engineers in Japan are very familiar with his techniques. And methods. And Taguchi's methods are His methods are more technical. So, management, all they need to do is should provide enough training so that people can learn and implement his methods on the shop floor or anywhere in the company. Taguchi doesn't ask for improvements at a revolutionary rate, but he's asking that management provides enough training so that people can learn and implement his methods on the shop floor and make quality improvements. Bottom line is, his methods and techniques and concepts they work. And it's been proven in the industry. So this concludes all the biographies of all our pioneers that we need to know about in this Six Sigma course. Our next lesson is going to be about organizational drivers, which will talk about linking projects to the goals. So this is it for this lesson, and I hope you enjoyed it, and please see the attached material along with the slide if you need to read more in detail. Have a wonderful day. Thank you.